Today we're moving on to 4.4, and it's about scientific notation in standard form. Okay, so we're going to be working on and learning how to write things in standard form and write things in scientific notation. Okay, so let's look at this concept here. Okay, so key concept of scientific notation. You start with this number here, 3,500,000. Now, that is the whole point of scientific notation, is to condense it, kind of like exponents. Okay, so we're going to condense it into scientific notation. So, whole point of scientific notation, we want a space, decimal, space. I always advise you starting like that. Okay? Because we want to get it to look like this. Now, how you determine what number goes in this spot right here? You're going to take your first whole number. Now, what are whole numbers?
Rational numbers.
Give me an example of a whole number.
3.
Does the whole number include 0? Oh, okay. So, here we want our first whole number. What is it? Starting from the left, what's our first whole number? 3. So I'm going to put 3 in my first placeholder. Okay, now we have a decimal. Now I want my next whole number on the other side. 5. And I want to account for all whole numbers. Is there any more whole numbers after that? No, only zeros. Okay, so that part's done. Okay, now we want to get this times 10 to the 6th power. Okay, it is always going to be times base 10. It's always going to have base 10. Now, the reason for that is because we are going to start moving the decimal. We want to get this number to look like this number. Okay, for 3,500,000, where is that decimal at right now? It's at the end, right? 0.0. So I want to get this to look like this, which means I need to move this decimal, right? Which way do I have to move the decimal to look like this? I got to move it left. Now we're going to count how many times we move it over. So we have 1, 2, 3, 4, 5, 6. That is our exponent. Okay, that is our exponent. What? Now, if we look at the one on the right, we have that 0.0000, however many zeros there are, 4. Now, start with those values, those placeholders. What value needs to go on the left? How do we know what value goes here? How do we know? We want our first whole number. What's our first whole number? 4. That's our only whole number, right? So, since we don't have another whole number, what needs to go over here? 0, right? Okay. Now we need to decide what our exponent's going to be on the base 10. How do we do that? Yep. You can count zeros, or you just want to try and get this number to look like this number, which means moving the decimal. Which direction do I need to move the decimal?
Left.
Right. So we go 1, 2, 3, 4. Sorry, 5. But that's in negative. Okay, now let me explain the powers here. If it's positive, okay, we are moving this decimal in the positive direction to get us back to our original number, correct? That's why we want positive. Or the other class like thinking it's positive, it gets me a bigger number. Okay, over here, we have to move our decimal in the negative direction to get back to this original number. Okay, but what they also like to thought about, if it was negative, we had a really small number. Does that make sense? It turns into a decimal. It is always going to be base 10. Okay, it's always going to have times 10 to some power. Why do you think it's base 10? Yeah, it's in the tens place. This whole decimal moving thing, whatever direction we're going, that only works when you're multiplying by 10, right? That's the only way a decimal moves, right or left. Okay, so that's why it's always base 10, because we're moving it tenths place in a direction. Okay, so let's talk about these examples here. We want to write these in standard form. Now, what that means, start with your blanks and your decimal. Okay, on number 1, we have 2 times 10 to the 3rd. Now, what is our first whole number? 2, right? I'm looking here. So we have 2 point, what goes on the other side? 0, because we don't have anything else, right? Now, it says times 10 to the third. What direction do I need to go, left or right?
Right.
We want to go right. Think of a number line. We have zeros, we have negatives over here, we have positives over here. The exponent's positive, we want to move in the positive direction. So we want to go 3 to the right. 1, 2, 3. My decimal's now over here. I need to fill those empty spots with zeros. Okay, because now we have 2,000. That's 2 times 10 to the third is 2,000. Okay, looking at 2, how do we do that? Times 10 to the fifth, we have 6.8. What direction do we need to go in? Right. Why do you say right? Because it's positive, okay? So we need to go 1, 2, 3, 4, 5. What do we do with all those empty spaces? Fill them in with zeros. Okay, so our new number is 680,000.
What?
Big number, right?
Big numbers.
On 3, what do you notice?
The exponent's negative.
The exponent's negative, so what direction do we need to move the exponent? To the left. 1, 2, 3, 4. Again, what do I fill those empty spots with? Zeros. So we have 0.000325. Yeah? You guys to try these next 3. Remember, keep in mind this number line. Think of your exponents. If it's negative, go to the left. If it's positive, go to the right. On A, up here now, on A, start with writing this number as a decimal. How can we write 3 as a decimal?
3.0.
3.0. Now we need to take care of times 10 to the 5th power. What does that mean? Which direction?
Right.
Right, because it's positive, so we need to go 1, 2, 3, 4, 5. What do I do with all those empty spaces?
You put zeros.
Fill zeros in. So what's my new number? Yep, 300,000 is my new number. On B, it's already written as a decimal for you. Now we need to take care of times 10 to the 4th power. What does that mean? Move it 4 times to the right. So we have 1, 2, 3, 4. Empty space becomes a 0. So we have 43,950. Last one here. It's already written as a decimal for us. We have 6.79, and then we have to take care of times 10 to the negative 6. What does that mean? What does the negative exponent mean now? We want to go to the left now. How many? So 1, 2, 3, 4, 5, 6. What do I do with the empty spaces? Zeros. So now we have 0.00000679. Now we're going to go backwards. Now we're going to be writing the times 10 to whatever power. Okay? So looking at 4 million, now this is when we're going to start using our little map. Okay? So we need to determine what number goes here. Okay, why do you say 4?
Because it's the only whole number that's not a 0.
It's the only whole number. And then what goes on the other side?
10?
0, right? Now we need times 10. How do we determine what our exponent is?
Figure it out.
What?
How many zeros on the zero?
Right, we need to turn this number into this number. So right now, where is my decimal at on 4 million?
The 10.
Right, it's at the end, right? So I need to move my decimal 1, 2, 3, 4, 5, 6. So my exponent is 6.
How come it's 10 to the 6th power?
It's always going to be base 10 because it's the 10th place and we're moving that decimal 1/10th place at a time. That's why it's base 10. Okay, on to start with our map up here. What number goes in that? Now, we need to determine what number goes in our first placeholder there in front of the decimal. How do we determine that?
The whole number.
Our first whole number. What's our first whole number?
4.
On number 2.
7.
7 is our first whole number. What goes on the right side of the decimal? 2, right? If I had a 6 and a 4 here, I would also need to put the 6 and the 4 with the 2 also. Okay? But you're always only going to have one whole number out in front. Now, what is our next goal? Once we have that written, we got to find what our exponent is, right? Yep. So find what our exponent is. We want to make this number look like this. So what direction do I need to go with my decimal?
Left.
On the top.
Oh.
We got to move it to the right. 1, 2. But is my exponent going to be positive or is it going to be negative?
Negative.
It is going to be negative because our number is getting smaller. Okay? All right. You guys to try these two on your own. Last ones. And these. Okay, I really want you to follow this idea. Okay? I think it will help. Blank, decimal, blank. We will always only have one value to the left of the decimal point in scientific notation. Okay? So, how can I write this number as a decimal, as it is right now?
8.
As it is right now, it would be 800,000.0, right? As it is right now. Okay, so to write it in scientific notation, what is my first whole number value? 8. Do I have any other whole numbers?
No.
No, so what needs to go on the right of the decimal? 0. Now, I want this to look like this. So I need times 10. What do I do with this decimal up here? Move it which direction? So 1, 2, 3, 4, 5. Is my exponent going to be positive or is it going to be negative? It is going to be positive because our number is bigger to start. Okay? Now on B, the number is already a decimal for us, so we can immediately go to this idea. What number goes on the left of the decimal? First whole number. What's our first whole number? 1. And then we have our decimal, and then what goes on the right side?
19.
The rest of our whole numbers. So we have 1 and we have 9. Now, we want to find our exponent. We want this number to turn into this number. What direction do we need to move that decimal? Right. 1, 2. Positive or negative?
Negative.
Negative because our number to start was smaller. Okay?
9.
Questions over these?